Hi guys, welcome to Piece of Code and welcome to this video. In this video, we're going to talk about disaster recovery on AWS. Now, many people may skip this topic, but I've noticed that a lot of questions actually come from this topic, and basically not directly from this topic, but what they do is they kind of mix around this topic with other topics like with S3 or with RDS, with EC2, with auto scaling groups. So they kind of take this and like wriggle it inside other topics, and they make it the options, they kind of make the options around this topic somehow. So as this is a kind of important topic, we're going to discuss this in this particular session, and let's move on. Right, let us first talk about what is this disaster recovery. So basically, any event that has a negative impact on a company's business continuity or finances is a disaster, right? It can be a natural disaster, it can be like a theft, or it can be a cyber crime, or whatever happens to your company and it results in a loss or a negative impact on your company is a disaster. So disaster recovery, DR, is about preparing for and recovering from a disaster. So what kind of disaster recovery, right? So basically we have, if you are running on an on-premise like a data center or something like that, we have traditional DR technologies, disaster recovery technologies, and they are very expensive. So for example, your data center went through a natural disaster and most of your servers got destroyed, then basically you have to buy new servers. That's very expensive, right? That's just an example, right? On premise, and then we have AWS Cloud. Then we can have a hybrid recovery. So you can have like a on premise setup, then you can have some kind of like a gateway, and you will have your AWS Cloud, and you periodically back up your data into your AWS Cloud. So in that case, it's a kind of hybrid recovery. Some of recovery you need to do from your on premises, and some of the recovery can be done from the cloud. So it's a better approach, and then it's a complete cloud, right? You keep a backup of all your data and your applications in a separate region itself. So if one region goes down, we just take that and put that as the master setup. It's a lot of strategies are there. I'm going to discuss those strategies in these particular session. Now two important, very important points that you need to know before going into this particular topic. One is RPO, that is recovery point objective, and another one is RTO, which is recovery time objective. Now both may sound similar, but they are kind of different, and they are actually different. Let us see what they each mean. So for example, some kind of disaster happened to your company. So RPO, which is a recovery point objective, means that how often you back up your data, so that if a disaster happens, like what data loss can you sustain. For example, you take backups like every hour. So the amount of data that you can lose, or you say it's okay to lose for your company, is like for 1 hour. If you do daily backups, then if a disaster happens, then you need to go back a day. So you can lose a day's worth of data. That is the recovery point objective. So your company can sustain a day's worth of data in this case. And it depends on you, like how frequently you back up the data and stuff. So it's completely dependent on you. So that's about RPO, which is recovery point objective. And it doesn't always consider the data. Actually, it can also be a state of an application. For example, you are running a current version of an application. For some reason that version is lost now. So like what all versions are you maintaining, like the previous versions that you can roll back to, that is also comes under recovery point objective. So that's about RPO. Talking about RTO, that is recovery time objective, as the T stands here, time, it just means that how much downtime can your application sustain, like 1 hour. So for disaster happens, so the users can sustain like 1 hour of downtime. But nowadays 1 hour is also too much. Maximum is like 15 to 30 minutes. But if you your application takes about a day of downtime, then that is very bad actually. That is very large RTO, right? So actually the RPO and RTO, things, differ. Like if you want to keep shorter RPO and RTO times, then it is better to back up your data frequently, and also, keep standby versions of your application running to reduce that RTO time, right? So we're going to discuss all these strategies. I hope you understood about RPO and RTO in detail. Now let us move on to the next slide. So what are the disaster recovery strategies that are there? One of the strategies is backup and restore, then there is a pilot light, then there is a warm standby, and then there is hot site or multi-site approach. Now depending on the type of recovery strategy that you use, the RTO actually varies in that case. So backup and restore is the most cheapest option, I will say, in the recovery strategy, but it has the maximum RTO. It means that the downtime will be the maximum time. Then comes the pilot light over here, then comes the warm standby, and then the multi-site. Multi-site has the fastest RTO. It means that the downtime is really less, but it will cost you a little bit more. And why it will cost you more, we're gonna discuss that in a minute. So let's move on. So backup and restore, it has a high RPO and it also has a high RTO, you can also say. So why is it that the case? For example, you are maintaining some data and app in your particular corporate data center, and you are backing up to the cloud using AWS storage gateway. Then what will happen? Periodically your data will be backed up, right? And when some kind of disaster happen, you just pull the data from the AWS cloud and then use it, right? So there is some kind of delay that is happening over there because you are pulling the data from some other source. You can also use a snowball device to store the data in a Glacier, because snowball you can directly unload the data into Glacier. You cannot unload the data directly into S3. So whatever, so you're storing it in Glacier, you can then create a lifecycle policy and whatever. But if you are using a snowball device, then the maximum time that it will take to reach the Glacier is 7 days. So it's kind of like you have to wait for 7 days in this case. So that is, you should not use it, but it's a way. So I'm just telling you. So this is a way of backupping your data into the cloud. And then there is other ways also. If your applications and your databases are running on the AWS cloud, then the best way to take a backup of those things is just schedule regular snapshots, because the snapshot feature is like available in like every service, right? Talk about EC2, talk about EBS, talk about RDS, talk about any other service which needs compute capacity. Snapshot facility is available, and there is a fast snapshot feature. It's very, very important, guys, to remember that particular fast snapshot feature in EC2, which is very, very good. Because restoring a snapshot is much faster, so this will actually reduce the RPO in this case. So these are the strategies. And if you are running any application in EC2, you can create an AMI, right? And for example, if the EC2 your application goes down, you can just load the data back into another EC2 instance using the AMI. And we also say it as a golden AMI, where what we do is we put all the applications and the data and then create an AMI. So if some kind of disaster happens, we just load the golden AMI in a particular EC2 instance. That's about it. And in RDS, you can just keep snapshots and stuff to create a backup of, and you can also create manual snapshots, whatever you want works for you. So that's about an overall about backup and restore. So the thing is, while backing up you and some disaster happens, you need to pull the data from somewhere. Even though sometimes it is faster, but still it has a high RPO. You need to remember that, high RPO and also RTO. So yeah, let's move on to disaster recovery strategy number 2, which is pilot light. Now what happens in this case is that a small version of app is always running in the cloud, useful for critical core. So for example, you can see in this case, you have a particular corporate data center, you have a particular application running. In this case, this is your main application, and what you are doing is you are having a standby EC2 instance on the cloud, but the core of your application is your data, that is your database. So you are doing continuous replication from your corporate data center database to the RDS on AWS, and you are keeping this RDS updated, only this RDS, not this application, it is still not running. So if some kind of disaster strikes to your corporate data center, what you will do, your database is already up and running, you just start your application and it will do the job, it will act as a master application. And you are using the Route 53, you can use multi-routing policy, so that you can switch back to this particular, or you can use a failover policy also. A lot of options are there to switch to this particular application, which is you're gonna start in the EC2 instance. Now it is not running, but when the disaster happens, you're gonna start the application over here, right? Then it will point to here, and this will be your main application. So that's about Pilot Lite. You keep the core system of your application running, and that is what it is. I hope that makes sense. So as you are keeping only the critical systems up and running, so the cost can be a little bit higher than the backup and restore feature, but it is still less as compared to other disaster recovery strategies, right? I hope that makes sense. Let us move on to warm standby. So it's a kind of a upgraded version of Pilot. So what happens over here is that full system is up and running, but at minimum size. So every component of your application is up and running in warm standby, but the thing is, it's a minimum size. You are not actually, if your application is like a 1 TB or whatever data it has, you are not keeping 1 TB of data in your backup. You are just keeping those critical data, and you are just running a small version of your application. That's it. But all components are running, but in a smaller way. So upon disaster, we can scale to production, and similarly we are using Route 53 to switch between your corporate data center corporate center DNS and your AWS cloud, whatever you have, ELB, and data replication is happening between your master database in your corporate data center and your RDS database that is in your AWS cloud. And this auto scaling, you are keeping it as at the minimum. So basically, for example, if your minimum capacity is 1 and maximum is 10, then at most you are running 10 instances, but minimum you are running 1 instance. So at all times 1 instance is always running. So if some kind of disaster happens, you just scale it up automatically. Maybe some kind of alarm you have set up. So what will happen? It will scale this up to like 5 instances. Now it can handle all the production load. So that's what is happening in warm standby. So upon disaster, we can scale to production, right? Pretty simple to understand. So multi-site or hot site approach, and this technique actually has the least RTO, which is recovery time objective. It can be minutes or seconds even, but the thing is, it's very expensive. Why? Because you are actually keeping a replication of your production load at a different place. So if any kind of disaster happens, you just switch over to that particular place. So for example, you are running the same exact copy of your production application on the AWS cloud, and you are using Route 53 as your DNS failover thing, and as disaster happens, it just fails over to AWS cloud, and it's an active technique. So basically both of those endpoints are like working, and they are working at full capacity. So yeah, that's the multi-site or hot site approach, and it has the very least RTO, and it has the most expensive approach, right? I hope that makes sense. So we studied about like the techniques of disaster recovery. Now talking about you can also keep the same kind of active approach in AWS completely. Now whatever techniques we have seen, it was kind of a combination of your corporate data center and the AWS cloud, right? But if your complete application is running on AWS itself, you can keep like the whole production application running in one region, and you can just keep another copy of that particular application in another region, and you can have an active approach, and you can have Route 53 failover policy in place. So if something happens or disaster happens in one region, it just switches back to another region, and the data replication happens between two Aurora global databases. Why a global database? Because Aurora global, it's a global database, so it's kind of accessible from any region across the world, and you're gonna pay a little bit more, but still, if you wanna have that least RTO, you're gonna have to pay for it, right? So that's what it means. So let us talk about some disaster recovery tips. First of all is backup, right? So obviously one of the tips is to take regular backups of your particular data, like your databases, your EBS volumes, and whatever S3 data you have. You can create lifecycle policies to transform the data from one storage class to a cheaper storage class and stuff. You can take regular EBS snapshot, RDS snapshots, etc., etc. And if you have a lots of data from your on-premise like data center, you can just request a Snow family device like a Snowball or a storage gateway, right? That works. So high availability, right? You can use those. What is a highly available architecture? Basically, if your service goes down, then if you have a highly available architecture, like you have a standby running somewhere, then it will take the place of the master, right? One of those techniques is using a Route 53, like a failover policy, so that it can get a active configuration, like we discussed in one of those strategies, like in the multi-region strategy and in the hot site approach, we use Route 53 active configuration. So that is a very good thing. You can enable caching, right? You can have a cache. If there is a cache hit, then basically what will happen is that the number of read and writes on your database and stuff will reduce. So it's a very highly available architecture. You can have multi-AZ, you can have elastic file systems. If multiple EC2 instances want to read from the same source, then you can have elastic file systems. And you can have, if you have a direct connection between your on-premises and AWS, DX direct connection, for some reason if it doesn't work, then you can have a backup site-to-site VPN, right? We have discussed this in the VPC chapter. You can go ahead and watch that particular lecture if you want very in-depth knowledge about these features. Now talking about replication, right? RDS replication, which is cross-region replication. If you use Aurora global, then basically what happens is that the database becomes available as a global service, right? And you can use RDS replication to replicate your database. So you have your master database, right? And you have another database, some in another region or another availability zone, and the replication happens asynchronously. There is asynchronous replication happening between your master database, this is the master database, and this is the slave database. So that is also one of the backup features, you can say, that comes under replication. And if you have an on-premises system, and you have for example AWS, you can have a storage gateway. You can use a file storage gateway or whatever Windows file storage gateway. We have a lot of types of gateways, right? So basically to synchronize the data between your on-premises and your AWS. That is one of the very good features that you can use. Coming to automation, you can so CloudFormation is a infrastructure as code, right? So basically till now what we have been doing is we have been creating infrastructure by clicking the buttons or through the AWS console. So basically using CloudFormation, you write some code and then AWS will take that code and create the infrastructure. You will write the code like, for example, I need 2 EC2 instances, I need 1 subnet, and then I need an elastic IP address. So whatever you need, you just write it in the code and you just deploy the code. That's it. And AWS will take the code and create those resources for you. It's a very good approach because sometimes what happens if your infrastructure goes down and you need to quickly rebuild that infrastructure. So basically if you just run that code and it will just take the steps in the code and it will just create that infrastructure. So it's very faster and it's a error free because you have already tested the code, right? So it's very error free and it's faster. So CloudFormation is one of the very good techniques that you can use. Elastic Beanstalk environments are basically a platform as a service environment. So what I can do is basically deploy your, for example, you have written something in Spring Boot, just take it and deploy it in Elastic Beanstalk. And there is another thing very, very important in Elastic Beanstalk, which is known as versioning. Like you can have multiple versions of your code that you have deployed. So for some reason, if your code is like down or something happened, some kind of bug happened, you can quickly roll back to the previous version. So that is called version. And you can use some in between lambda functions to create some kind of loopholes, or you can do some additional work or some kind of stuff. So that is called under automation. Now chaos is a strategy, I would say. Basically you induce disaster upon your existing architecture by the use of bots, or I don't know, by the use of some you kind of replicate that high, I would say, what it is called, high volume of requests on your particular servers. You replicate that so that you will see how my infrastructure is working to handle it. And Netflix has a simian army. It's kind of an army of requests, and they test it like every time, so that if our infrastructure is working fine or not. So that is known as a chaos strategy. What you do, you deliberately, for example, you have two servers running in one availability zone, US East 1A, and another server is running in US East 1B. So you deliberately just overload this US East 1A server, and it goes down, and you check that if this goes down, is my server in US East 1B working fine or not. If it switches fine to US East 1B, then you can see that okay, my infrastructure and my disaster strategy is working fine. So yeah, that is how you introduced chaos into your particular infrastructure. And actually all these techniques are very, very important, guys, because just creating an application and running it is not it. Monitoring, logging, and disaster recovery kind of accumulates about 60 to 70% of your efforts, because if you cannot sustain your application, then it's useless. That's it. Let's move on to database migration strategies, because questions come from this particular topic, and you need to know that the most important thing that you need to keep in mind while learning about disaster recovery is that your data, you should have some kind of strategy, so that if something happens, you can migrate the data quickly, or you have that backup somewhere and just grab that data quickly. So it's a technique of quickly and securing migrate database to AWS, resilient and self-healing. You don't have to worry about anything. Use the service and you are done. Supports homogeneous migrations, for example, from one database to Oracle to Oracle. It means that you have an Oracle database somewhere in your data center, and you can directly migrate it to RDS Oracle or something like that. Heterogeneous migrations, like you have Microsoft SQL and you are migrating to Aurora, that is also possible. And you can do continuous data replication using CDC, right? And then you must create an EC2 instance to perform the replication task. So basically what happens over here, you have a source DB, and there will be an EC2 which will run DMS, which is database migration service, and it will act like a medium for your replication tasks, right? You can also change some tasks in between, like some modifications you want to make. You can do this, and you will understand the importance of this intermediate EC2 instance when you are migrating from a heterogeneous source, like from Microsoft SQL to Aurora, because you have to do some conversions in between, and we're gonna learn how we can do those conversions, like how we can handle those conversions in a minute. So we have that particular intermediate EC2 instance running, and then we have the target DB, which can be, for example, in AWS like Aurora or SQL, whatever you want. Cool, right? Now, so DMS sources and targets, you need to keep in mind. You need to keep in mind what can be the sources and what can be the targets, right? So on-premises and EC2 instances databases. So any kind of source which is like in your on-premise database or your EC2 instances can be a source. So your source can be also a database on the cloud also. So what kind of databases it supports? Oracle, MySQL Server, MySQL, MariaDB, PostgreSQL, MongoDB, SAP, and DB2. SAP and DB2. Azure, from Azure you have some from database in Azure. You can also select that, like Azure SQL database. And Amazon RDS, you can, as I've told you, right, your source can be any database on the cloud also or on the on-premises setup also. It's fine. And from Amazon S3 can also be a source. And targets are basically on-premise and EC2 instances. So basically you can migrate an on-premise database to another on-premise database. It's possible like this, right? And basically this is what it is. Then Oracle, targets can be also Oracle, MySQL Server, MySQL, MariaDB, PostgreSQL, and SAP, Amazon RDS, Amazon Redshift, Amazon DynamoDB, Amazon S3, Elasticsearch Service, Kinesis Data Streams, and Document DB. Right. So these are all the sources and the targets for DMS or data migration service. Now this is known as very important AWS Schema Conversion Tool or the SCT. Now this is where your intermediate EC2 instance, which comes between your source DB and your target DB, is actually works. Now convert your database schema from one engine to another. For example, you are converting from a MySQL, Microsoft SQL Server to Oracle. You can use this schema conversion tool because even though those are type of SQL databases, still there are some differences in the schema, right? Maybe some data types differ, or I don't know, some kind of rows and columns differ. I don't know. It depends on the schema, right? So what will happen? You are converting from an OLTP server like a SQL Server or Oracle, MySQL, PostgreSQL, Aurora, and you are converting to SQL Server or Oracle to MySQL, PostgreSQL, or Aurora, right? So different source and different destination you have. And if you are converting in kind of a OLAP database like from Teradata or Oracle to Amazon Redshift, so what happens in this case? We need to convert from one schema type to another schema type, and we have to use the schema conversion tool for that. And this is a very important question in the exam also, because they ask you like what tool do we use if we use the database migration service to convert from one schema type to another schema type, or from one source type to another source type, and your answer should be a schema conversion tool. And this EC2 instance which is running over here, it will contain the DMS, which is database migration service, plus the schema conversion tool. It will do all those heavy lifting, and it's gonna do all of those heavy lifting for you guys. And prefer compute intensive instances to optimize data conversions. And if you remember our EC2 lecture, I've told that when it comes to computational intensive tasks which require a lot of processing power, you have to go for the compute optimized family, right? You will get more number of cores and more number of processors, so that these conversions, which are a lot of computations, it will be handling seamlessly, right? So I hope that makes sense over here. And you do not need to use SCT if you are migrating the same database engine. As I've already told you, this SCT comes in hand when you are migrating from a different data source to a different data destination. If you are migrating from PostgreSQL to RDS PostgreSQL, then it doesn't make any sense, because these are the same database engine, right? So I hope that is clear. Now continuous replication, basically what is happening, a server with AWS SCT installed, this is right. So basically what you are doing, you have a corporate data center, and basically you are doing the data migration, and you have a this AWS DMS replication instance which is running in the public subnet, obviously, because if it is not in the public subnet, how will we reach that particular instance, right? We have to use its DNS name or its public IP address to reach there. So do the data migration task. This is the intermediate EC2 instance, right? And this EC2 instance is connected to the Amazon RDS MySQL DB, which is the target, and this is the source, Oracle DB source, and this is the MySQL DB target. So obviously this is running SCT plus DMS, right? Because we need the schema conversion tool, and then it's actually replicating it to the target, right? And schema with the schema conversion. Because if we do not use SCT over here, basically what will happen is we are not able to convert from one database engine to another database engine. I hope that makes sense. So in DMS, basically, to remember the most important points in DMS, we have one is the EC2 instance, intermediate EC2 instance, and if you want to convert from one source engine to a different destination engine, we use the SCT, which is the schema conversion tool. That's all you need to remember about DMS, and this is enough to answer your questions on DMS in the AWS certification exam. Okay. Now what about RDS and Aurora MySQL migrations, right? So basically from RDS MySQL to Aurora MySQL, there are certain options that you can follow. Option 1 is DB snapshots from RDS MySQL restored as MySQL Aurora DB, because you see in our in RDS and in Aurora, what happens is that we can restore a database from a snapshot. So if you have a RDS MySQL snapshot, you can restore it as a Aurora DB, instance. There is another option which says create an Aurora read replica from your RDS MySQL DB, and when the replication lag is 0, promote it as its own DB cluster. What is a replication lag? It means that so what happens in read replicas? We have your master database, and we have the read replica, and replication happens in between these two databases. When replication lag equals to 0, it means that whatever data is in this particular master database has been replicated successfully in your read replica. When this replication lag is 0, we would say that okay, master database and the read replica are on the same terms in terms of data. So what we can do in this case is that we can promote our read replica to be a master database, because see, by default read replica cannot act as a master, because it will only handle read operations. To actually promote it to handle read and write operations, we have to promote the database to be the master. So that is option number 2, to promote your read replica to a master database. Now if you have external MySQL to Aurora MySQL, option 1, use Percona extra backup to create a file backup in S3. So you just create a backup in S3 and create an Aurora MySQL DB from S3. That is one option. Basically you use the Percona extra backup to create a file backup in S3, you upload it there, and from that particular place you import it to a Amazon Aurora instance. That's what you're gonna do. Option number 2 is using the MySQL dump facility. It's a utility actually. So basically MySQL dump will take all the data from your MySQL table and then put it in the Amazon Aurora database. Now the thing is, all of these features that you are doing, this extra backup and this MySQL dump utility, you need to stop the database server for that, because while the database is running, you cannot dump everything in the database, right? So that is one of the drawbacks, and this is where people get confused in the exam also. Always remember, if the question in the exam asks that you have to replicate one database to another database, and in the meanwhile both the database should be in running conditions, there should be no downtime, guys. In that case you will use the data migration service. And if the question states that if there is no barrier in like the downtime, and also we need the least cost method to transfer the data from one database to another database or do the migration task, then it is better to go with the MySQL dump utility or the Percona extra backup, because those are kind of cheap methods and also it requires the database to stop for some time. So yeah, keep these things in mind while answering the questions in the exam, guys. Alright, I hope that makes sense. Now the similar thing about RDS and Aurora PostgreSQL migrations. So RDS PostgreSQL to Aurora PostgreSQL, option 1 is similar as the previous slide. Use the DB snapshot to restore your particular database, right? Second option, to create Aurora read replicas, that is the same thing, and then promote it to your own DB cluster or your master. External PostgreSQL to Aurora PostgreSQL, create a backup and put it in S3. It is the same kind of technique, but for SQL you have to use the Percona extra backup and import it into AWS S3 Aurora extension, right? And the same thing, if you want both the databases to be in running conditions while the backup is happening, then please use the database migration service. All right, I hope that makes sense. So on-premise strategy with AWS. Now basically what happens in this case? You are running a certain environment in your on-premise and you want to replicate or migrate it to AWS. So what are the strategies with that? So basically you have the ability to download Amazon Linux to AMI as VM. So you can download it as an .iso format. Basically then you can, as you have the particular Linux as a .iso format, you can install it in all of your servers. If you want to like install it in your on-premises servers, you can do that. VM import export, migrate existing applications into EC2, right? So basically you can do that. There are also techniques for that. Create a disaster recovery repository strategy for your on-premises VMs. can export back the VMs from EC2 to on-premises. You can do that. Basically, there are a lot of techniques you can do this thing, right? You can create ISOs or golden AMIs, or create an AMI and download it and just install it in your on-premises servers. Actually, there are techniques where you can migrate a VMware that you use for virtualization, right, from on-premises to AWS and vice versa. That is also possible. Let's talk about AWS Application Discovery Service. Gather information about your on-premises servers to plan a migration. So the thing is, this service will help you to plan a migration. It's not migrating actually, it's planning a migration. Because see, when you are planning to migrate your on-premises servers, or I don't know, databases and a lot of caches, a lot of stuff is there, right, in your on-premises setup that you're gonna have to migrate it to AWS. So you have to first plan it, right? You cannot just grab one of those things and just put it in AWS, and if that doesn't work with any other thing, you have to redo everything. So this application discovery service will help you with the mappings, with the server utilizations, and what service of AWS should you use or replicate your on-premises systems. All these information will be provided by an application discovery service. And then we have AWS data migration service for databases migration, right? And there is AWS server migration service or SMS. It's known as SMS. It uses to create incremental replication of on-premises live servers to AWS, right? Now, AWS backup is kind of like, a lot of questions come from this AWS backup. Very small topic, but it comes. Why? Because it's a centralized service. You can keep a track of all your backups across all your services in AWS using AWS backup. No need to create custom scripts and manual processes. What are the supported services? You can keep a track of all your EC2 and Amazon EBS snapshots or backups, Amazon S3, Amazon RDS, all DB engines, Amazon Aurora, Amazon DynamoDB, Document DB, Amazon Neptune, EFS and FSX backups, and then AWS Storage Gateway and Volume Gateway backups. All of these features you can track at a central place, at a central dashboard, and you can use it. So because in the exam they may ask a question, you are running a system on AWS, you are running an application on AWS, and you need to keep a track of all those servers and backups that you wanna do. Like you wanna create the backups every 7 or 10 days of all of the services that you are using in your application. What is the least operationally overhead solution to do this? And there will be a lot of bigger answers which will say do this manually, do that manually, and then create a script and then just join everything and do all kind of hell. But the thing is, there will be one small option over there which says use AWS backup utility. That's your answer. That's it. It's a very simple solution, but it's a correct solution. It also supports cross-region backups. It also supports cross-account backups also. Right? So you see, you have AWS backup service, and then you have create a backup plan, like what is the frequency of the backups, how many days you want to retain your backups, and the policy. And then you assign the AWS services to that particular policy, and it is automatically back up to Amazon S3. And you can see a lot of services are there that we just discussed. Right? I hope that makes sense. Correct? Great. Now talking about AWS backup vault lock, and if you remember this vault lock concept we have discussed in S3 actually, and it's basically you create a lock on the data that is present somewhere, and its common term is known as a worm, write once, read many times. So what happens? You create an additional layer of defense to protect your backups against malicious delete operation. That is the most important thing, why this worm feature is actually important. You don't want your data to be deleted by someone else. You want to retain your data. You want to put a policy on the data that nobody will be able to delete it, right? And even the root user cannot delete the backups when this particular policy is in place, right? Backup vault policy. You can compare it to S3 worm policies, or object vault lock in S3, in Glacier, and something like that. It's the same thing. Now talking about the application discovery service, guys, plan migration projects by gathering information about on-premises data centers, Server utilization data, dependency mapping are important for migrations. Whatever informations you need to plan your migration from your on-premises to the AWS, you will use the application discovery service for that. You get all the utilization data, all the mappings that you need between your services, and a high level of how your particular architecture is gonna work. There is two types. We have agentless discovery, AWS agentless discovery connector. It provides you with VM inventory, configuration, performance history such as CPU, memory and disk usage. Then there is agent based discovery, provides you system configuration, system performance, running processes and details of the network connections between the systems. So resulting data can be viewed from the AWS migration hub. You can keep a track of and you can see that what is happening in this particular migration strategy, right? That is about application discovery service. Not much to remember about. Just remember, if in the exam there comes a question which says you have to plan a migration from your on-premises to the AWS, then please go for application discovery service, right? Application migration service, we have MGN. So this is the discovery service that we learned, and then we have application migration service. It's the AWS evaluation of cloud endure migration, replacing AWS server migration service or SMS. So what is this thing? You take your, if you remember, there are a lot of migration strategies actually, right? And one of those strategies is lift and shift. So what happens in lift and shift migration strategy? You just take everything that is in your corporate data center sorry, in a corporate data center, you take everything at once and you put it in the cloud. That's it. So you do not make any modifications, you do not make any changes, you take it as it is and you put it in the AWS cloud. For example, you are running a lot of OS apps, DB, disks, on the disks in your particular corporate data center. You use AWS replication agent, you do a continuous replication of your architecture. So this is the staging area actually, because before deploying it to production, you want to check that everything is working or not. In the staging area, you use low cost EC2 instances and EBS volumes, because obviously you just want to test like how is this lift and shift operation is happening, it is working or not. So in the staging area, you do all this using low cost EC2 instances, like for example T2 micro and stuff, and then you do a cutover to the production. So if everything is working fine and the replication is worked fine, then you just go, okay, it's production ready, so you can just put it in the production EC2 instances and EBS volumes, and basically your production EC2 instances and EBS volumes are much more powerful than your staging instances. That's how your application migration service works. You just do a lift and shift, or rehost your particular solution that you have in your corporate data center or in any other cloud provider, and you just put it on the AWS cloud. That's it, right? It supports a wide range of platforms, operating systems and databases. It has a minimal downtime and it has reduced costs. Great. Now, as I've told you, remember mentioning this feature, that is VMware Cloud on AWS. So some customers uses VMware Cloud to manage their on-premise data center. So they want to extend the data center capacity to AWS but keep using the VMware Cloud software. So we have, if they are using VMware in their on-premises data center, we have VMware Cloud on AWS. So actually you can see that AWS actually provides you with whatever migration strategy that you need, any kind of migration server service or whatever you want, AWS provides it to you. What are the use cases? Migrate your VMware vSphere based workloads to AWS. Run your production workloads across VMware vSphere based private, public and hybrid cloud environments, and have a disaster recovery strategy, right? So you have your customer data center, right, which are running on premises vCenter vSphere based environment. So you can just we use the VMware Cloud on AWS. Whatever vSphere based environment you have, this service provides you with that vSphere, VMware NSAN and NSX. Whatever you need, you use those VMware facilities you need, it will be provided by this particular service, and then it will just run everything else in the AWS services that we have. So whatever environment, VMware environment you have, you can replicate it on the cloud using the VMware Cloud on AWS. Simple as that. And I'm not showing any kind of demo or something like that, because these are actually bigger things and I do not have any corporate data center as of now. It will cost you a lot. From the exam perspective, you just need the information and the understanding that this is how disaster recovery happens on AWS, right? So what do you do when you have large amounts of data that you need to transfer to AWS? For example, you need to transfer 200 terabytes of data in the cloud and we have a 100 Mbps internet connection. First option is to do over the internet or a site-to-site VPN, and it is very immediate to set up. That is the thing. If the question asks that we do not have any time to wait, we just need to go directly with the least operational overhead, then you will go with the site-to-site VPN, and your site-to-site VPN with a 100 Mbps connection is actually fine, it will work. But the thing is, the time is the important thing, how much time it will require to transfer the data. So we have 200 TB into 1000 GBs into 1000 MBs into 8 MB by 100 Mbps. This conversion is because this is in bits, right? So we have to convert into, capital B, that is megabytes. So that's the thing. And then we have how much time we are taking: ones, tens, hundred, thousands, 10,000, lakh, 10 lakh, crore, 1.6 crore seconds, which is 185 days, which is equivalent to 6 months. So if you can wait for 6 months and you need the immediate setup, then please go with the site-to-site VPN. But I don't think any question will ask you to wait for 6 months. So that's not a better solution. But if you have a direct connection which gives you about 1 gigabits per second speed, the thing is the setup time is more. In this case, the setup time is very less, can be nearly a day. You can do it in a day or even less. But in this case, for establishing a direct connection, you need over a month time. So if you are good with waiting for the setup, in the question if it asks, okay, we are good with the setup, you can take about a month, then you can go with the direct connection. It will take 200 terabytes into 1000 gigabytes into 8 GB by 1 gigabytes per second, which is nearly 18.5 days, right? So it's much faster. It's 18.5 days, nearly 10 times we have reduced the time, right? So in this case, how much time it will take? 30 days plus 18.5 days, which is 48.5 days, which is less than 185 days in a nutshell, right? But the thing is, in this case, the snowball family is actually going to work the best. Why? Because you just order 2 to 3 snowballs in parallel. So it will take 1 week for end-to-end transfer. So only 1 week to transfer the data from your source to the destination cloud. And you can combine it with DMS. So the maximum wait time that you can do is 1 week. So for the snowball devices to reach you, maybe it will take 1 week, and from your source to reach it to the cloud again, so because you order that device, put the data and then send it back, right? So for that, take 1 week, something like that. So total it will take 14 days. That's it. So it is the least amount of time from all of these 3 options, right? So that is the thing you have to think about in the exam, like what is the feasible solution, right? I don't think that site-to-site connection is a very feasible solution when it comes to like 200 TB of data. You have to choose either between a direct connection or the snowball. So if in the exam it says we already have a established direct connection and we have like 10 gigabits of bandwidth or something like that, and we have to transfer 200 terabytes of data, in that case direct connection is pretty much the best solution. But if they say that we don't have a direct connection, we do not have the time to set it up, we have tons and tons of data and we need to transfer or migrate the data to the cloud, in that case the snowball will work the best case. And for ongoing replications and transfers, use site-to-site VPN or DX or DMS or data sync. DMS stands for data migration service. I hope that makes sense, guys. And this is how I'm gonna answer the question in the exam, and I've seen that a lot of questions that comes from this disaster recovery concept. And yeah, that's it about this lecture, guys. I thought about making a video on this because a lot of questions actually are coming because from this disaster recovery strategies. So I hope you guys understood whatever I have taught in this particular lecture, and we're gonna see what we're gonna cover in the next lecture. Till then, have a nice day, bye bye, and best of luck for your preparations.